Group, good evening. Today I am going to start with conjugate of a complex number and multiplicative inverse and some questions of solving the quadratic equations using complex numbers. So, if a plus iota b is a complex number, if I write z as a plus iota b, I denote the conjugate of complex number. Conjugate of a complex number as z bar, and z bar equal to z bar is equals to a minus iota b. So in conjugate you will change the sign of the imaginary part. For example, if z is 2 plus iota, z conjugate is 2 minus iota. If z is minus 2 plus iota, z conjugate is minus 2 minus iota. If z is say 3 minus iota, z conjugate is 3 plus iota. If z is minus 4 minus iota, z conjugate is minus 4 plus iota. Whereas if z is say minus root 2, this is root 2 iota. Don't misunderstand as 2 iota. So z conjugate is minus root 2 iota. So this all is about the conjugate of a complex number. Hope it's clear to everyone. Now, conjugate has many applications, especially the application in finding the multiplicative inverse of a complex number. Now, multiplicative inverse, as you know, if you take up all natural numbers, and multiplicative inverse of 1 is 1, or you can take all positive real positive rational numbers, multiplicative inverse of 2 is 1 by 2. So even if we take multiplicative inverse of a complex number a plus iota b, it's 1 upon a plus iota b. I can write it more clearly, 1 upon a plus iota b. Now, to make it more clear, you can't leave complex number in this way. You have to simplify, and in simplify you have to make the denominator real. So how to make the denominator real? You have to multiply numerator and denominator by its conjugate. So you have 1 upon a plus iota b into a minus iota b, a minus iota b. So that is a minus iota b upon a square minus iota b whole square. Well, that is a minus iota b upon a square plus b square. Well, that is the multiplicative inverse of a complex number, though I will show it by numerous examples. Now, suppose the question is find the multiplicative inverse of 4 plus iota. Now, multiplicative inverse of 4 plus iota is 1 upon 4 plus iota. This, of course, you will simplify. You will multiply the conjugates 4 plus iota into 4 minus iota. This is 4 minus iota upon 16 minus iota square. This is 4 minus iota upon 16 minus of minus 1. This is 4 minus iota by 17. So this is the multiplicative inverse of 4 plus iota. Now, similarly, find the multiplicative inverse of, say, iota upon iota plus 1. Now, its multiplicative inverse this will be 1 plus iota upon iota. Now, again, you have to simplify this to make it in standard form, like in this form we make it. So, it's 1 plus iota into iota upon iota square. Now, iota square is minus 1 plus iota upon minus 1, that is 1 minus iota. So, the multiplicative inverse of iota upon iota plus 1 is 1 minus iota. So, likewise, you can calculate many multiplicative inverses of the complex numbers. Now, another example, find the multiplicative inverse of 2 plus iota upon 3 minus iota. So, its multiplicative inverse is 3 minus iota upon 2 plus iota. Now this is 3 minus iota upon 2 plus iota into 2 minus iota into 2 minus iota. Well, this is 6 minus 3 iota minus 2 iota plus iota square upon 4 minus iota square. Well, that is 6 minus 5 iota minus 1 upon 5. This is 5 minus 5 iota by 5, that is 1 minus iota. So this is the multiplicative inverse of 2 plus 3 iota upon 3 minus iota. It's 1 minus iota. So like this you can calculate the multiplicative inverse of many questions, though I will give you one assignment. There you have in NCERT, you will find many questions of this type. Now I want to prove one thing. If z is a complex number, prove that z plus z conjugate is real. Now proof. See, here you have to prove, you have to take general complex number. You can't take any value. Let z is a plus iota b. Z conjugate is a minus iota b. So z plus z conjugate is 2a. This is 2a. And since a is real, so 2a is also real. So you have the proof. Hope it's clear. As a belongs to real, 2a is again belongs to real. So z plus z conjugate is real. Now come to the solving of the